Hi everyone, I've made us a little app so that we can have a look at how correlation and regression are related to each other. And this video is just to go over that. This is a little bit more complicated than what is online for you, but it's just to go over to show some of the things that we can do here. Now, what I've done here is we've created a random generation process. So we've got y is equal to beta times x plus a random error. In this case, there's no constant in the regression or in the linear line here. We're just looking at the coefficient of the slope and that relationship with correlation. So we can manipulate what the beta is between 0 out to -2, which is a very steep line there, and 0 out to +2, which is a very steep line going in the other way. Don't worry about this one, this is for another day. We can also have a look at different sample sizes here and see how that changes what these scatter plots would look like. So fundamentally, these scatter plots show a relationship between y and x. And when we have a positive relationship, the line's heading upwards this way with various strengths. When there is almost no relationship, so this was when beta is equal to 0, rho is just equal to -0.04 there. It's just really a big random mess in the middle there. Okay, but if we go the other direction where it's negative, you can see the line's getting steeper and moving in that direction. So really, the correlation coefficient and the regression coefficient, they're strongly related to each other in this context. So what I want you to take away from that is direction. And what I've done into here is this automatically generates the correct interpretation for the regression coefficient. So if we take a regression coefficient of 0.4, then for a 1 unit increase in x, we would expect a 0.4 unit increase in y on average. I don't know why there's an x there. It won't go away no matter what I do in the code. Okay, so this will show you how to interpret the slope coefficient. So for a 1 unit increase in x, we expect a 1.2 unit increase in y on average. And over here, for a unit increase in x, we expect a -1.4 unit decrease in y on average. So the important parts of that interpretation there is that it's always for a unit increase in x in the independent variable. Occasionally you'll see people bump that up, say for a 10 unit increase, if that coefficient is very, very small, and they multiply that up by 10. But generally it's for a unit increase. We expect a regression coefficient increase or decrease, this -1.4 here, unit decrease in y on average. So two really important points here. We have the expect and on average, very important. And you can see that if there's less of a sample size, different things happen here. This isn't on the web app, but that comes back to what we were discussing about hypothesis tests earlier in the week. So I hope this app is useful for you. I've put the link up on the discussion board. Feel free to have a play around. It looks a little bit different on the web. I've simplified it a lot, and hopefully it helps explain what's going on there.